Daniel works at Jumping World. Last week he worked for 12 hours and made $93.84. How much does he make per hour? Show all of your work. Well, if we look at this first, he made $93.84. That's what his check was for. Since that was what his check was for, that's actually his net pay. That will tell you how much his net pay is, just so you know. How much does he make per hour? If you see something money-wise, or anything that asks how far per hour, how much per minute, anything like that, it's going to be a division problem. And the two things you're going to need to know for this problem is how many hours and how much per hour. How many hours and how much per hour. So that tells us it's a division problem. So if we write our equation is going to be hour equals $93.84 divided by 12. You could see it as H equals, let's see, 12 times H equals $93.84. So you can see it written several different ways. All we have to do is figure out what 12 divided by $93.84 is, or what times 12 equals $93.84. Because we know that division and multiplication are inverse operations. When doing division, I have begged you 4,281 times, please write the multiples of your divisor. So if we're doing the math and we have $93.84 and we're dividing that by 12, my divisor is 12. I need you to multiply, or I need you to write the multiples of 12 as we go through it. So if I do 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. 12 times 6 is 72. 12 times 7 is 84. 12 times 8 is 96. And 12 times 9 is 108. 108. First of all, you should have these memorized, okay? Second of all, once you do this, the hard part of your math is done. Once you do this, the hard part of the math is done. So now let's look at doing the division. In our dividend, we have a decimal point. When there's a decimal point in the dividend, we just move it straight up. If your divisor is a whole number, your decimal point is in the dividend, you just move it straight up. Now, we need to figure out, if we estimate, am I going to have more than $10 for my H, for the number of hours? Well, 12 times 10 would be 120. So I know I'm going to have a one-digit whole number. A one-digit whole number. So I'm not going to have anything in the tens. But if I take 12 into 93, I can go over here and I look at which multiple is closest to 93 without going over. Well, 96 is too big, so it's got to be 12 times 7, which is 84. That has to go in the ones place. It's important to put the digits in your quotient in the correct place, over what they go. So that is 84. And if I subtract that, I'm going to get 9. Now I bring down the 8. Bring down my tenths place. This is going to be my tenths place. So how many ever times 12 goes into 98 is going to go in my tenths place. So to go into 98, it's going to have to be 8, because 96 is as close as we can get. So now we have $7.80 something cents. Bring down the 4. I can get to exactly 24 in my multiples. So that's going to be a 2, and that would be 24. Now I want to check it. If I'm going to check it, I can multiply, because multiplication is the inverse of operation. If I think H, the number of hours, equals $7.82, which is what I think, that is my answer based on the math I did. To check it, I would multiply 12 times $7.82 and see if it equaled $93.84. Follow the steps, and it's not that difficult. All right, we have done this problem before. Bertha used a table to write fraction pairs for a composite number. Fill in the rest of the factor pairs to complete the table. Well, first we need to know what a composite number is. A composite number has more than 2 factors. If we look here, this is going to show us all of the factor pairs. This tells us how many we need to have. What many of you did when we were doing this problem the first time is you did 2 and 60, 3 and 90, 4 and 120. But you would be able to keep going forever. And that's not what it's asking, because it says fill in the rest of the factor pairs. Well, factor pairs. What multiplies together to equal 30? Well, 30 is an even number, so 2 is a factor of every even number. So when we ask ourselves, 2 times what equals 30? 3, if I add the digits together, 3 plus 0 is 3. 3 is a multiple of 3, so it would be 3 times 10. It is a multiple of, or it is a 5 is a factor because it ends in a 0. So 5 times 6. These are the factor pairs. So if I wanted to find the factor pairs for 30, 1 times 30, 2 times 15, 3 times 10, 5 times 6. Notice I use the divisibility rules because that makes it far easier when I'm doing factor pairs. Using the divisibility rules are way easy. Way easy. So which model represents 6/10 divided by 2? We are starting with 6/10. Starting with 6/10. So our picture that we have, the model that we have, needs to start with 6/10. That starts with 12 hundredths. This one is 6/10 divided by, or multiplied by 2 hundredths, or by 2 tenths. This one starts with 6/10 and it divides it into 2 equal groups, because that's what we're doing. We're dividing into that many equal groups. So this is the one, starts with 6/10 shaded in. You'll notice that it's divided into 2 equal groups. Each of these groups is equal. So 6/10 divided by 2, the picture is going to look like this.